All right, hello Algebra 2 students. This is Mrs. Short. I'm going to go over the first day of your learning here with you on exponential functions. And this is a new topic that you've never seen before, and it actually kind of relates to what's going on with our coronavirus these days, but we'll get into that later. All right, so first I want to go over some functions that you already know. Now, I tried to type the least amount that I could on here so that you could basically just handwrite these notes, or if you would prefer, you can print out the notes. The PDF file will be available to you as well. All right, so absolute value. So absolute value functions, you guys know the good old absolute value problems, absolute value of x, and those were like a V-shaped graph, right? When you graph these things, they look like that. All right, and you can move them up, down, left, right, all that. Then we learned quadratic functions. So quadratic functions, you learned them two ways. There was ax squared plus bx plus c. That was one format. That was standard form, and then there was vertex form. So a x minus h squared plus k. Remember that was vertex form because h and k were your vertex, and you moved it around, up, down, left, right, that kind of stuff. So remember that was a U-shape graph, the parabolas and quadratics. All right, then you had polynomials, which was kind of like, a quadratic is a polynomial, but polynomials had higher degrees, usually like 3 or 4 that we studied. So maybe you had ax to the third plus bx squared plus cx plus d. And remember those graphs would be like, you had a cubic function with those twists and turns, or it could get more complicated. And yeah. So also excuse my writing here. I'm trying to write as best I can with this pen that I have on my iPad. Anyway, so then you had square root and cube root functions. So remember a square root function where you had the square root of x, or cube root, you would have the cube root of x. So the square root function was started here and kind of curled up. The cube root function, remember that kind of curved over like this. Right? And then you had exponential functions. So actually you didn't have exponential functions. That's what we're going to do right now. So an exponential function looks like this. It's y equals a to the x. So a is supposed to be a number. And so like we're going to do our first problem is going to be a 2 right there. So our first problem is going to look like this, 2 to the x. So the reason it's called an exponential function is because, like you see right there, there's a good old x in the exponent. So we call it exponential. And so there's more to this. You can move these things left, right, up, down, and so on. But we'll talk about that later. And then this guy right here, logarithmic functions, that's the next thing coming up, but we won't be doing that today. Alrighty, so on to our first example actually, let's review a little bit still about transformations. So transformations, remember back in the beginning of the year when we started with something like this, like absolute value of x minus 2, and then we had plus 5. So remember that moved you to the right 2 spaces, and then that moved you to up 5. So this was like your inside the bars was at your right and left motion, and your outside part was your up or down. Then you could have had a negative sign out here to do a reflection over the x-axis. You could have also had a number right here giving you a stretch or a shrink. So we're not going to get that complicated with you just yet, but we're just going to kind of do the basics. So remember, you could also do this with any function. Like let's say you had a square root function. You would have, square root x plus 3 minus 1. So that square root function was moved to the left 3 and then down 1. And so that's where it started. And then it was just your good old square root function from there. All right. And so I just want you to remember those transformations, and all those things that we did kind of look the same. So when you see them with exponential functions, you're going to already pretty much know what to do. All right. So here's our first example, an exponential function. So we're going to start with the basic exponential function, y equals 2 to the x. So that 2 right there, that's called your base because it's the base of an exponent. And then you have x in the exponent. And so that 2 right there, that's a number bigger than 1. I want you to recognize that. So our exponential functions go into 2 categories, either growth or decay. And so you're going to see that in the graph when we get to it. So let's start off like we would in Algebra 1 just by making a table. Let's do our x's and our y's. So I'm going to have 0 in the center right here and do like 1, 2, 3, and 4. And then we'll go backwards and do -1, -2, and just -3. How about? All right, so let's start with 0. If I plug 0 in to my problem, so I'm plugging that in right here, remember. So I would have 2 to the 0 power. So remember 2 to the 0, that's 1. And then I would plug in a 1, so 2 to the 1. that's 2. And then 2 to the 2, that's 4, and so on. And then 2 to the 3rd, that is 8. So if you notice a little pattern right here, when I jump from one thing to the next, I'm just multiplying by 2. So if I don't want to figure out what 2 to the 4th is, I could just look at the pattern and be like, oh, 8 times 2, that's 16. So if I go backwards, it's like I'm dividing by 2. So that's what you hear about on the news all the time when like this problem is doubling, like every time you put a new number in, like they say how, the virus is doubling every day, the amount of people that have them, or so anyway, that's what an exponential function does. It can grow or decay depending on your base of 2 or whatever base you have. So let's go backwards. So if I'm dividing by 2 to go back, well, 1 divided by 2 is 1/2, and 1/2 divided by 2 is 1/4. And 1/4 divided by 2 is 1/8. So if you don't know those things, you can also do this. Like for instance, this guy right here, that would be 2 to the -3. Well, that's 1 over 2 to the 3rd, so that is 1 over 8. So you can figure out however you like. So let's graph these things. So if I make a graph, I just do a quick XY table or XY axis. All right, and so I'm just going to kind of freehand it a little bit because we can go to Desmos and get like a nice clear picture. But let's see. So 0, 1. So I'll put that right there. And then 2, let's see, 2, I'm sorry, 1, 2, 1, 2, I can't read my own writing. Then I would go over to 3 and go up to 8, so it gets pretty high pretty fast. And then 4, 16, it's really kind of off my picture here. So I go -1 and 1/2, oops. And then -2 and 1/4, so it's getting smaller. And then -3 and 1/8. So what's happening here, it's never going to be negative. So if I were to draw this, it's going to end up looking like this. It's going to shoot up really fast. All right, so a couple of things going on here. Notice that all my answers, they're all positive. So that means that what's happening here is there's kind of like a blocker in a way. This graph, this red graph, is never going below the x-axis. And so that turns out that every exponential function has what's called a horizontal asymptote. And this horizontal asymptote on this picture is y equals 0. So this asymptote can move around. If your graph moves up or down, then the asymptote is going to move with you. It doesn't have a vertical asymptote. All right, and we can talk about its domain and range. The domain, you can put in any number you want in for x. So your domain is all real numbers, or -infinity to infinity. Also, this graph goes left and right forever. Your range, well, your range here, you saw that the graph is not touching 0, and it's not going to touch 0 or go below 0. So the range is starting at 0 and going on up to infinity. So basically, sorry, it's ugly. So basically, our graph kind of starts right above 0 and goes up from there. Okay. All right, something else to notice here when we're looking at this picture. This graph is increasing. So when you look at increasing, decreasing, you start at the left side of the graph. So just like you're reading a sentence, you start at the left, and if you notice, oh, the graph is rising. Now, something else when I was doing that, do you notice that this is not rising that much or that fast, but then it starts to increase really fast, all right? And so as x increases, y increases at a faster and faster rate. So let's write that down. As x increases, y increases at a faster and faster rate. Sorry, I know my writing's atrocious, I'm sorry. All right, so this would be an exponential growth problem. And I'll tell you later, but that has to do with the base right here. When you have this base right there, it's going to tell you whether you have growth or decay. All right, I think I've done everything I want there. Let's go on to just a couple more examples and then we'll be all done. All right, so for my next two examples, we're just going to real quick talk about transformations. So my next example, I have y equals 4 to the x plus 2. All right, so this is going to be that thing where, we're moving up, down, left, or right. So notice this 2 is after the whole problem. So if you look back at what I was talking about before, that plus 2 is kind of like what this is doing right here, or what this 1 is doing right there. So this is going to take my graph and move it up 2 spaces. So if I were to go ahead and do a table, I would get a graph that pretty much looks like this. It's going to go through 0, 0, 1, if I was just doing y equals 4 to the x, and so that would be here. So this would be like y equals 4 to the x. It kind of looks like 2 to the x, but you don't really notice the difference because we don't have any points on here. Oops. All right. Now, if I basically move everything up 2, what's going to happen is, that asymptote that I used to have right here, that has to move up 2 spaces as well. So my new graph is going to look like this. My asymptote will now be at y equals 2 going across here. And my graph will shift up right there. So my graph used to cross at 0, 1 for my basic thing, but now that gets moved up 2 places as well. So that's going to be at 0, 3. Right? That's going to be my y-intercept, and my asymptote is at y equals 2. So again, your domain is all real numbers. Your range is going to be basically everything above 2. So 2 and up. Okay, so my next problem, I'm just going to make it a little bit more complicated. I have 3 to the x plus 2 and then minus 4 out here. So we all know that that minus 4 right there is going to move me down 4. But this x plus 2, this is with your x. And so that should remind you of these problems here. Whoops, sorry. Right there. Anything with the x moves you left or right, those pieces right there. So since this one has a plus 2, that's going to move me to the left 2. And there'll be some Desmos activities that we have posted later that you can do to solidify this. But let's go ahead and graph this on Desmos and see if we can see what's going on here. I do know from this that my asymptote is going to move down 4, so it's going to be down here at y equals -4. And the graph's going to look pretty much the same as the others. It's going to move to the left too, but let's go on Desmos. So if you go to Desmos, then you can always graph these things. All right. So I want y equals, and I have 3. So 3 to the x plus 2. Oh, it didn't go up there. So I need to have my plus. Dang it. All right, let me put some parentheses there and see if that works. There we go. So I guess I got to put those in parentheses, then jump over and then do -4. All right, so you can see what we're talking about there. There's the asymptote at y equals -4. And here's an x-intercept right there. I'm sorry, a y-intercept. There's an x-intercept if you need it. And so this basically gives you an idea. This graph is increasing from left to right, and it's also a growth problem still. All right, so last problem. So let's just look at one little thing here, and that would be if we had a reflection. So if you have a reflection, what's going to happen to you? Like, let's say you have y equals -2 to the x. So 2 to the x is what we did originally. 2 to the x was, remember this like nice basic graph that we had before, everything doubling every time we put a new number in. So a -2 to the x, so this is y equals 2 to the x. A y equals -2 to the x is going to reflect us over the x-axis. So that one's going to basically, like, we say flip in a way. But anyway, remember this spot used to be at 0, 1. Well, now that's going to be at right there. It's going to be at 0, -1. Now, this did not affect our asymptote. We basically kind of flipped over the asymptote. So our asymptote is still y equals 0, but that was a reflection over the x-axis. All right, and so that was a transformation that happened there. All right, so this graph would now be decreasing because when you're starting on the left-hand side, it is starting here and it's falling, so it's decreasing, and it's also decreasing more and more and more, faster, I guess you could say, as you go from left to right. And looking ahead in the next lesson, we're going to talk about equations or exponential functions that would be something like this, like 1/2 to the x. So when you start to have a number right here, when your base is between 0 and 1, what you're going to get is a graph that is decaying. So this graph would be decaying, starting from the left really high and coming down. So we're going to talk about that next time. But your job is to do the math space assignment, the 10 questions assigned to you for this day 1 of exponential functions. Hope you have a great night, and I'll see you later. Bye-bye.